sites that have some really cool new stuff, and you have some sites that are still in the old days. And you finally have legacy vendors from SDI world who are now putting IP interfaces in their product plans. And so it's an interesting time. And it's a time, I think, that you're going to start seeing more and more people come from that traditional media and entertainment world and their devices, their hardware, and their protocols, and they're going to start coming here to the IETF. And I think this trend has already begun with a few people, people like myself. And so we thought we'd give a bit of a talk and a bit of background and perspective from a couple different views on where we're at right now, what's been going on in that transition, and what the transition looks like to hold for us in the future. So from that perspective, let me introduce my panelists. The first one is Gaurav Naik. He is a professor at the Drexel University. His interests span both computer networking and cybersecurity, and much of his work has been on exploring the design of network applications, protocols, and software-defined networking. He's also a veteran of the IETF. He works in segment routing, and if you've been to Bits and Bytes and saw some of our GG demos, Gaurav has been heavily involved with myself and others on working on some of the GG stuff we've been playing with. We also have Craig Taylor. Craig is the lead technical architect for the BBC's online technology group. They're responsible for the design and performance of BBC's media delivery platform and the internet edge of the BBC web. Often working as a liaison between research colleagues and engineering, Craig contributes to video, audio, and internet standards and transitions them into production platforms. Craig provides development details for transport application security protocols across the BBC. And finally, but not least, we have Mark. Mark is a Cisco fellow. He's a part-time professor at École Polytechnique in Paris, and he's the co-founder of Cisco's Paris Innovation and Research Lab, PEARL. He's a longtime contributor to the IETF. Mark served 2 terms as the Internet Area Director for the IETF and has chaired multiple working groups. Mark also leads the IPv6-centric networking program at Cisco, researching ways that IPv6 can be used to solve networking challenges in ways unthinkable with IPv4 alone. And so our first panelist to speak will be Craig Taylor. And Craig, we'll bring you first slide. Take it away.
Hello, everybody. Can everyone hear? Marvelous. Hi, I don't do this very often, so apologies for the obvious anxiety. But I'm Craig Taylor, work for the BBC Online Technology Group, as you've just heard. I don't have any slides today. I thought I'd spare you all of that, so I do have a short video and a lot of words, but we'll plow through them quickly. So here at the IETF, I've been coming since IETF 89. You'll typically find me in working groups such as HTTP and QUIC, but also some of the transport areas. My unique specialism is typically that I don't have one. I'm a massive generalist, so I apologize for stomping all over anyone's area with light level detail. At the BBC, we're a public service broadcaster. So we're based in the UK, which is obvious. We deliver our contents worldwide. And we have a strong relationship with our audiences, which is based primarily on trust. So being a public service broadcaster, we have different biases than perhaps some of the attendees that may come here regularly. We are compelled to provide our content to markets that in some cases don't necessarily even exist. We have strong reach requirements, etc., which takes us into schools, etc. We're already in the process of re-engineering our IP workflows. We have various production facilities around the UK, some in the north, some in the south, and they're heavily built on legacy technologies such as SDI for video transference. Our new facilities, which is active work, which we're building as part of our IP Studio project, are using things like SMPTE 2022, 2110, and this is largely just a restamp of SDIs. So functionally, the workflow doesn't change, just the distribution mechanism. The work that we're researching and prototyping now, which I have a short video of here. This video is captured on a desktop and is a demonstration of an active mixing process. this research is based on object-based or atomized media, where at the capture phase, the media at the point of capture, we render media objects and persist that metadata end to end throughout the production chain. So if I can take that video.
Yep. You ready?
Yep.
Hang on.
And also Glenn's email.
I can't see. Yeah. Left up over here. Where's the mouse? What does that say?
The other one here.
The other one. Yeah. I cannot see what I'm seeing.
There you go.
You have no idea how far behind I'm on things. Okay, here we go. From this angle?
Is there audio?
No, there's no audio.
Oh, in which case I'll talk over it. This demonstrates captured atoms which are being rendered in real time on an edit suite. We're able to identify individual presenters to provide things like accessibility benefits. The presenter is just one video atom that can be interchanged, just as the tiling at the back is, where you can provide a high contrast display for the visually impaired. Subtitling, when moved onto the screen, can actually interact with other video dogs, so that you can render either as part of the edit process, or even on the playback device itself, the appearance. I actually have a longer version of this as well, which shows a portrait style viewport, where the high value objects, i.e. the presenter, can be rendered whilst the viewport is changed to meet the target device. So think of it as almost, what's the word? Sorry, words failing. It's similar to, sort of the way that we render web pages these days. You can render to the specific viewport whilst retaining those assets. So the challenges in providing this kind of experience are sort of largely timing based. At the point of capture, there are very strict time constraints surrounding when the media objects are captured. They then need to have consistent enough metadata through the chain to be able to be rendered either at an edit suite or at the end device. So those are the opportunities to create a far more flexible workflow within both the edit and presentation of the media, but that also creates several challenges for us in distribution. We already have some volume-based challenges, which some of the larger video distributors will be quite familiar with, but in this case, we're demuxing those media objects now, and so we end up with a larger carousel of objects in which to draw from. So this is where I get back onto some of my more bread and butter things, because I largely do distribution, if I'm honest. The distribution challenges we have already are, as again a public service broadcaster, are that you can't always guarantee that the audience in certainly the UK has a data line that is that has enough bandwidth to receive all of the media over a unidirectional flow. So we require to be flexible on the type of access networks that we might use in the future. Something like LTE broadcast may be essential to reach our audiences. So we're trying to be both flexible with the distribution mechanism, but also to improve upon the way that we're doing that. So some of our work here at the IETF is to try and engineer a common layer 7, which is independent of the access method. which we've had some conversations here, and we hope to have a draft refreshed on soon. We also have very different client failure constraints in the broadcast world compared to regular sort of web delivery. On a large screen device, people are very intolerant of video rebuffering or stuttering, more so than perhaps they are in a web-based world. So that consistent nature is difficult to achieve in a way that is sort of homogeneous across devices. Another aspect of being a sort of service provider in that context is I have to hit every device that moves, and so that presents certain other client application challenges. And finally, just to tag off, because I've no idea how much time I've used, the biggest challenge for us is just the sheer volume in many cases. The UK is just one small space, and in the UK, we may at some point, in fact, probably will at some point, lose our primary access method, our broadcast access method, and replace and have this replaced with an IP mechanism. Just to scoot through some numbers for that, our largest peaks to date in that market are 24.5 million concurrent viewers, which are about 70% of the audience. If you scale those numbers up to UHD at 24 megabits, you've got, that works out at about 588 terabits concurrent from one content service provider. If you translate that into commodity servers, 40 gig attached in a truly cached model, that's close to 15,000 servers if they are deployed with near 100% efficiency. And UHD is where we are today. We'd like to do 8K, we'd like to do VR, we'd like to do more 360. Those compelling visual experiences that we're trying to work on will just consume more bits. And that's me done.
Thank you, Craig. So next is going to be Grav. And Grav, I have a question for you here.
Yep.
You know, as the media production industry moves towards IP, are there any advantages that IPv6, which I know we've had a lot of discussions about, does that provide?
Yeah, so Glenn, I think as the media production shifts towards IP, there's kind of an opportunity to go IP end to end. And in media and entertainment, end to end means from the lens of the camera all the way to the viewer in their screen. And Mark said that IPv6 is a platform for innovation, and I completely agree. For example, today there's a very large content provider that's assigning IPv6 addresses to containers in their data center. What we're thinking about is, what if those containers were actually pieces of data, video or content, right? So today we take a video, we break it down into individual files, and we'll put them on a CDN. What if instead we take the video, we break it down into individual chunks that can be addressed using IPv6? And if we do that, we can take advantage of the speed, the simplicity, and everything that IPv6 routing gives you. We also increase the sort of visibility across the entire media production distribution chain by having that metadata at the IP layer. So later today, we'll be showing kind of a live demo of this concept, and you're seeing a screenshot of the live demo above. What we've done is taken 3 movies, we've broken them down into individual chunks, and prepared them with IPv6 in mind. We deployed them to 2 CDNs, and the 2 CDNs are on the right side of the screen, CDN 1 and 2. And both CDNs are using BGP to signal their reachability to that individual content. And we'll show you how, and we'll demonstrate how that content can be addressed and accessed directly using IPv6 by the 3 viewers, the 3 screens on the left side in the home. And we'll show that how using accessing content this way and combining it with Anycast, you can get smooth, kind of uninterrupted failover in a stateless way. So I encourage everybody to attend to come see this demo. If you've seen some of it before, we've made some changes and enhancements to it. And there's also going to be other cool demos from other people of working running code.
Thanks, Grav. Next up, Mark, would you like to share your perspective on this topic?
Happy to. Thank you very much for paying for this panel. Thank you very much for coming here and having some food and listening to us talk. And one of the best parts is I already knew Gaurav pretty well, but one of the best parts for me for this panel is getting to meet Craig. He's got a lot of really great insights across how IP, how this transformation is happening both on the media production side as well as on the distribution side. If I'm waiting for Glenn to figure out the start of the presentation. That's the end of it. There's a start. Well, backwards, all the way up. Okay, now you've seen everything.
We're professionals.
Anyhow, so when Glenn introduced me, he mentioned that I am a co-founder of the Cisco Paris Innovation and Research Lab. He also said that since he's paying for this, I'm allowed to do marketing. So this is my marketing, just telling you that we exist. It's a really fun group of people. Those of you that know us here, Eric Vinke here and Pierre Feaster and some of the others that have been coming to the IETF, we do lots of bits and bytes and lots of hackathons and things like that. And we work a lot in IPv6 and do a lot of networking kinds of things. But this lab also is full stack all the way up to the application. We've got a video immersive lab, and I'm about to be talking about some of the media production stuff that's a little bit more down Craig's line here in just a moment. Next slide. So shift happens. As has been mentioned up here, and the topic of the whole discussion is that IP has transformed distribution and is continuing to transform distribution, moving up into primary distribution, moving up into the broadcast being eliminated and moved to terrestrial, moved to IP. Also, this is moving up into the media production side, and the problems look different there than they do in distribution. We don't just have video, we have raw, uncompressed video that has certain timing constraints, and I think Craig covered some of that. So next slide. In a media production center, there's a lot of different vendors that you might not have heard of unless you play around in this area. This is an eye chart here, but if you had binoculars, you would see lots of different company names. It's a boutique industry in that sense, and they're all new to IP. Not all, many are new to IP. I just say all. So this is something we did in Paris back in October with a number of different partners. It's not just Cisco. Working with France Television, where we had their headquarters, where they do all their production, and they're used to doing it all on site, right? For like live broadcast, breaking news kinds of stuff. Well, that little orange line is a fiber connection across Paris. That's in there in the middle to a remote production facility. And we did a big interoperability test to see, can we do live video production remotely, right? It might seem trivial. Of course, there's an internet. Of course we can do that. But it's actually a really big deal, especially with all the interoperability involved. So standards are important. Next slide. So again, I get to do some marketing. In our lab, we're working on various new things. We have an orchestrated live video production data center. Okay, it's a platform to model the various workloads, and it's great that Craig just told me that he's defining his IP workflows right now, because that's what this is all about. It's orchestrating those workflows from a media production standpoint. We've got several demos and proof of concepts and things that we've delivered to various partners, including like native 4K video production, a video pipeline. Now we're using a container-based infrastructure to do the workload placement. This is Kubernetes, et cetera. But the video pipeline itself is IPv6, segment routing, some of the latest new stuff that the IETF is working on in order to get those efficiencies to be able to push the bits as fast as possible through that production data center in the most predictable way that we possibly can. We have other things, video newsrooms, virtualized sports shows, et cetera, but in the interest of time, you can ask me later. Next slide. This is a little video, and it's the dashboard of this orchestrated media production pipeline system. We can go in and you see, you know, various containers running and various different servers. These mean probably more to Craig than they do to me. But we can, this is basically modeling a newsroom working closely with Coronigo, which is one of these boutique companies. They were Chiron and Hago, and then they combined and they became Coronigo. And they make this kind of stuff. Now, that kind of stuff traditionally runs on Windows-sized machines connected together with SDI coax cables, okay? Now, the shift that's happening is first those coax cables become IP, then they become virtualized, lift and shift, virtualized workloads. That's more of what you're seeing there, right? But ultimately, once you have that flexibility, you can reimagine everything. And just the Windows-sized components of workflows lined up and in you know, redundant fashion, so that if anything happens, you can flip over and you have a fully redundant setup. All that kind of goes away eventually when you have the power to like spin up, you know, hundreds of thousands of containers, when you can burst into public cloud and all that kind of stuff. So that's sort of the next phase. And that's what we're working on. One of the things we're working on at our Research and Innovation Lab. Thanks.
Thank you, Mark. So we've heard sort of about what's been going on and what people are doing. So let's talk a little bit about the future here and stuff that's maybe on the near-term horizon. Gaurav, can you maybe, so V6 is great, right? We've all heard V6, we love V6 to the IETF. It's a bigger address space. So what other features beyond more addresses are we going to get if we can actually do video over V6?
Yeah. So I'm glad, I think Mark mentioned segment routing for the V6 data plane. And so for the people that don't know, the idea with SRv6 is you encode a series of 120-bit structures where segments are essentially IPv6 addresses into an extension header called SRH. And each segment represents a topological instruction, maybe a link or a node, and you can use the SRH to steer a packet through a path in a network. And the idea is that this list of segments sort of in the SRH represents a network policy that you're kind of pushing to the edges of the network. Now, if we go back to our fully IPv6 media network, can you bring up the thing? So with SRv6, we can describe paths that media takes through the network. So on the distribution side, of course, it'd be very useful if you could cache, let's say, a video stream in the path of delivery from one of the CDNs to the screen. But what if you wanted to cache out of the path of delivery? And SRv6 lets you do this. So in our demo, we have a home cache. So the home cache is there in the top middle in the purple. And using SRv6, and as you see, it's not necessarily in the delivery path to the screens, but using SRv6, we can now cache data anywhere V6 can essentially be routed to. There are a few other examples that SRv6 enables, such as load balancing, allowing you to put state information into a packet or a flow and pinning clients to specific servers. There's some really neat things you can do with multicast type of structures if you need to do replication where you don't have multicast available or you necessarily can't be deployed. You know, I think overall SRv6 is probably one of the most exciting things that's happening for IPv6 right now, and it's going to make really media workflows far more flexible, agile, cost-effective. And on the academic research side, I think SRv6 has enabled new research really involving how applications participate in their network traffic.
Thank you, Gaurav. Thanks, Gaurav. So, Mark, I'm going to call on you and ask you, what's your opinion on that same topic? What about sort of virtual workflows and things like that?
Well, you'd said, okay, IPv6, we love it, a lot more addresses. It's a lot more addresses. Not just a lot more addresses. A lot more addresses.
How much more?
And 30 orders of magnitude more.
That's a lot more.
That's a lot. And so one of the things that as part of the IPv6 centric program at Pearl is we are looking at, you know, like, what does that mean? And it can reverberate all the way up and down through the stack, right? I can now address at least, if not route to, and use things like segment routing to a named object that is a v6 address. And Craig talked a lot about having objects and the metadata associated with them move all the way from media production through distribution and eventually to the end user, which I think is the whole glass to glass dream, right? And I think that having looking at it from top down, Craig's looking at it, okay, I want layer 7 to be constant because I want any kind of access network. Looking at it from bottom up, it's okay, well, if you have an access network that has great reach and the granularity to address an object, can you use it, right? And that's sort of where the two come together. The use case that Gaurav mentioned of being able to steer a path through, a video oriented path, like because it's 8K, because whatever, is a great example. You can also use segment routing to search for a particular object so that you don't have to have, perfect synchronization of all your routing tables everywhere. You can sort of have a directed anycast, if you will, towards an object. That's something that if you want to go, if everybody should have IPv6 here, and at least in the building. And so if you want to go to 6cn.io, it's a website set up by Eric Vinke and some of our students and researchers at the lab in Paris. And you can see a lot of this kind of stuff with doing distribution to v6 addressed objects. You can even upload your own video, and you will have your own globally unique v6 addresses on every 2-second chunk of that video. Feel free to do that and populate our database. But I think there's a lot of opportunity, great research topics, and even near-term products.
Thanks, Mark. We've talked a lot about V6, and so it's pretty clear the panel kind of likes V6. But
We are at an IETF.
But this isn't just about V6, right? There's a lot of other aspects of things that we work on here at the IETF. There's a lot of things that we are actively engaged in developing and things we're talking about doing in the future. And so Craig, I'm going to ask you. So I know you're active in the Quick group because I see your email on the list. Could you maybe tell me a little bit, explore what other groups do you go to here at the IETF? What do you find as a video production person, a video distribution person? What do you find relevant here during your week to go visit and participate in that you think, as we bring more video people in here, where should they be going, I guess, is part of the question.
That's a very interesting question. My week is typically quite full. The areas in which we contribute are different than those, I suppose, where we have more of a watching brief on at the moment, but that's probably just a factor of the amount of time and effort that we've currently got invested in individual groups. As I think certainly contribution area or content producers involvement is quite young, I think, in IETF terms. I think there will be more interest as time goes on. HTTP, Quick, absolutely. But then transport area working groups, etc. It's a very interesting question when you ask people. Minor segue, I hope you don't mind. If you ask a broadcaster what real time means, so some of the work that's going on in ICCRG and TSVWG surrounding reducing latency, buffer bloat, etc., are exceptionally relevant in the broadcast space, and that's because of this sliding window of how you ever get a broadcaster to answer what they mean when they say real time. Which is, to someone in the capture space, it might be 10 milliseconds with a standard deviation of near zero. In a contribution part of the network, they've got 100 to 150 milliseconds to play with. In distribution terms, we can talk about integer seconds, so we're a bit happier there. So it's across the spectrum. If you look at my calendar, I think it's about 4 or 5 areas.
So you keep busy. You keep busy.
Yeah.
Okay. So I want to open up to questions from the audience, but let me say a couple things. If you went into a studio today, which is producing content, and that is part of this transition, where once you might have seen a wall of equipment that was all connected with cables all over the place, and very messy, right? Racks of equipment, but all SDI connected. In that same studio today, what you might be very likely to see is a switch and a router. And everything, in the modern world being captured, float over IP to editing and other work facilities physically remote from where the studio is today. And that's also part of the transition. It's the ability to move people and virtualize where the work is done and do it at will. It's very powerful. And it's the same stuff we've seen in other industries as we've transitioned. So let me first do 2 pitches, and then we're going to take some questions. Number 1, if you want to talk more about this talk, because we have a very limited time, we have to be out of here by 1:15 to get the next session in. So this evening we grabbed one of the breakout rooms, the Troil, I can't even do it. Anybody speak Czech? The Trojka room. It's up on the mezzanine level. From 6 to 7 p.m. just before Bits and Bytes, and this is after Quick. So if you go to Quick, you're good, and then you can come to this, and then you go have a beer at Bits and Bytes. Come talk. We're sitting there to talk. It's sometimes we're not specifically going to talk about GG. We're not specifically talking about anything. We're talking about the specific of video at the IETF and stuff like this. Carry on the conversation. We like to hear what you're doing and what you're thinking. And of course, don't miss Bits and Bytes tonight. I mean, come on, free beer and food and demos. You can't beat that. Okay, so let's take some questions from the audience. And somebody keep me off sometime.
Yes.
So I'm Peter Peterka from Very Matrix. This question is for Craig, but pretty much for all of you. The television industry started with broadcast, right? And then when we started moving to IP, it was IP multicast. And now everything seems to be point to point. And Craig was talking about 15,000 servers to just deliver television. Are we ever going to go back to multicast, or are we staying with unicast forever?
So I'm going to use host, moderator discretion first and jump in and give my 2 cents, and then you can answer.
Why not?
Why not? I think multicast has a big part of the potential future for doing stuff, but I think we should also always keep in mind that we have people that watch very long tail stuff. So there are still people right now, somewhere in the world, somebody's watching Knight Rider. Okay, and that's not something that 5 other people are doing. It's that one guy watching that one episode. And so multicast is a solution in many places, but it's not the only solution. So we should never think in terms of a single solution ever. And then Craig.
I deploy things, so I'm a ruthless pragmatist in many senses. So IP multicast isn't available in a pervasive context. I can deliver to small multicast islands, and actually in the UK certainly there are several IP TV platforms that already rely on and use multicast on a day by day. You can't deny the growth in on-demand context, especially even with live, with sort of live or instant rewind, etc., starting back at the the head of a program. And so for me, the future is flexibility. This is why I'm after looking into concepts like having a common layer 7. It's actually about reusing those objects, no matter how they were delivered and in what time base. Yes, IP multicast is a thing, but will it be pervasive? Probably not. And also, you still need to try and discover your media in some way. And actually, we have a whole raft of how do you discover your multicast, and is it encapsulated in the same way? And now do I have to do a lot of heavy lifting in my application? And it's so flexibility. Flexibility is important.
And Craig missed an opportunity to market something he did that's very cool. In Chicago at the Bits and Bytes, and I think at the hackathon, you guys demonstrated a thing you had worked on, which allowed you to merge into a multicast stream and then break out when you're doing trick play stuff and then merge back in. I thought that was pretty awesome. So talk to him about that. It's very awesome.
Yeah. So I mean, actually, Lucas, who's just over there, is one of the key engineers in that. But yes, absolutely, we're looking at effectively multipath with QUIC, where you have a bidirectional unicast flow with and effectively using multicast as an optimistic upgrade on that. But the layer 7 semantics are the same.
Next question.
Sajjad from Mohammed University. I have a question regarding IPv6 use for these sort of applications. Like, are you assuming the use of a flow label with it, like these sort of applications?
Mark, Gaurav,
Maybe. You know, if you're on a network where the flow label means something, and you happen to have a flow that you know that needs to be balanced with the flow level, sure. I don't think it's a critical part of the architecture, but if it's there, use it.
Stuart Bryant. So first, a lesson from history. Many years ago, people thought that 48-bit MAC addresses was an infinity of MAC addresses, and we're now having a crisis because there aren't any. So when we go to the fine-grained addressing of media content through IP addresses, when do we expect to run out? And to go with that, what's the consequences of this for the routing system itself with very large quantities of disaggregated addresses?
well, so I'll do that. So I have done the math on do the number of bits, and forgive me, I'm doing this from memory because I made it written down. But I worked out at one point that you could, with smart allocation of the address space, but still supporting variable bit rates, you know, a la dash or whatever, you could handle what I predicted to be all of YouTube for decades to come. And YouTube's huge in terms of the number of videos they have. In I think it was like 2 to 32 bits to actually do the addressing of their content. So the secret plays also to the routing tables. The secret is to allocate addresses intelligently to content. Just don't blast them out and leave the whole thing sparse. If you aggregate and you do it smartly, it works. Mark, Gaurav, any other comments?
Yep. So it's great being able to work with a guy who you know comes from the content owner side of the house, because they number all their content in many ways. So this is just yet another way. But to the running out of IPv6 address space, there's the whole history of 640K is enough for my memory, 32 bits will be enough for my v4 addresses, my IP addresses, whatever. If we get to the point where we're really running out, oh, what a wonderful place that would be, right? I don't think it's going to happen anytime soon. And if my grandkids have to create another IP, fine. But so be it. So I think we shouldn't be afraid to use the additional granularity that we have. And it's not just for something like content. Certainly in a world of containers and microservices, where you have IPv6 addresses on all of them, and this is how Facebook does everything in their data center. It's one of the largest in the world, right? And there's even architectures where the addresses are ephemeral. They won't reuse them for years, right? And the microservices are coming up and down on an average of like 1 or 2 seconds. And these are all just v6 addresses. And it sounds to our minds that, oh, you're going to run out because we're so used to being careful with the v4 addresses. But 30 orders of magnitude bigger is a lot bigger. And I think we'll be okay. I don't want to be scared.
And I misspoke. The calculation I did as I got done speaking, I realized it was 2 to the 56, not 2 to the 32, but 2 to the 56, which still fits really nicely inside of a 128-bit address. Okay, I think we're just about up on time here. We have probably time for one question.
I have a question.
Mark has a question. Okay, Mark has a question first, and then we'll take this last question here.
Craig, what is an atom? How big is it? And, what does that mean to transport across the network? You mentioned atoms in your video. I want to know what that is. I know what ants and elephants and mice are, but I don't know what an atom is.
It's a logical concept more than anything. It's whatever you want it to be. It's whatever you can or want to uniquely describe about an editorial experience. So in the example we showed, I mean, it was using a sort of traditional green screen. So the presenter was an atom, the backdrop was an atom, but there was an alternative to both of those, some additional atoms, the dog on the screen, atoms, subtitles, atoms, audio atoms. So it's effectively abstracting any one object that you may wish to change. In real terms, it's more difficult to go beyond those individual things that you capture. But our research team is already working on taking things that are not uniquely captured and atomizing those as well. So actually take a regular 2D presentation. It's relatively easy to isolate the presenter and actually take them out of the shot and reuse that elsewhere. So it, anything that you can capture, but anything that you can extract from that which you've captured.
Okay, and it's code and data. Does it have behavior, the object, or is it just data?
Anything that you would like to describe with some kind of metadata. I mean, this is the point. The opportunity here is an extra degree of editorial control, an extra degree of flexibility. This conceptually is, I mean, what we're talking about here is almost a simple engineering exercise. It's not until you release that to the editorial creatives that you understand what they really want to do with it.
I'm hearing that video isn't analog anymore. That was my takeaway from that. Sir.
Magnus Westlund. Yes. About privacy in this system, I mean, I've discussed with you before, etc., around the kind of prototype so far that they leak massively about what you're actually viewing on the network layer. You can see all the individual users, exactly what they're watching and where, etc. And I hope we will have a better privacy stories going forward if continuing to evolve this. So
I will invite you to come down to the demo tonight. We'll talk about that because we've got some very ideas that we think are very practical solutions to allow you to have anonymity while watching content. And with that, Mark, do you have a final comment?
I was just going to say, demos are demos, and what's interesting is the large address space, allows you to either, swing all the way towards knowing exactly what content is on the wire, all the way back to being able to mask it, perhaps even a lot better than with IPv4 today, because you could change, like privacy addresses on steroids, if you will, right? So, and I'm sure Glenn's going to show you some interesting things along those lines. It ends up being, we build the technology here, and at some point you do have to put something on the wire that means something to be able to route it. But it's, a matter of some combination of regulation, what the consumer will accept, what the business will accept, your terms and conditions, whatever, that I think will ultimately dictate, how many bits on the wire somebody can glean information about.
And there's a lot of addresses to hide behind anonymously. So I think come on down by the event at Bits and Bytes, grab a beer, come to the booth. We'll be happy to talk. And with that, I'd like to round of applause for our speakers that took their time to come talk to us today. And thank you for coming.
Thank you.
So we'll do that. Exactly.
Oh, okay. And Mark and Craig don't run off yet.